I start with a little introduction. Then I'm doing I think it's better to discern between low-level and high-level AI. Then I give a market overview of AI services, some user examples. So I really tried out some of the providers and services, hands-on, so to say. Then the biggest problem I'm going to talk about is that most of the services are really black box. And in the end, a little wrap-up. So AI, everyone is talking about it. It's really, a big hype topic nowadays. So it means actually that a lot of things that are easy for us humans are very difficult for machines. For example, recognize cats in pictures, walking, grabbing things from a table, and so on. In the 50s, the first researchers started working on how to make machines more intelligent, since they were just machines at the time. So they started to break the problem down into a lot of sub-problems. So, for example, how can a machine deduce, infer, make predictions, or make decisions? Then how can the knowledge be represented? And how can the machine logically reason with that knowledge? Another problem is planning ahead, like in games or in navigation. Another problem is read and understand human language. Then another problem, understanding the surroundings of the world. So how to perceive the surroundings around you. This is mostly related to robotics, like walking, grabbing stuff from a table. And finally, social intelligence, like it's called affective computing. So recognize, interpret, process, and simulate human affects. The last part I've put in anyway, it's general intelligence, which combines all the others together. But in my humble opinion, we're not even close to this yet, so we're all safe. So in the 90s, we had some early adopters in the industry, like military anyway, financial industry, and aviation, for example, with dynamic pricing. And now, especially in the last 10 years, the usage of AI was spreading hugely, mostly driven by the advances in deep learning. So nowadays, AI is a bit of a hype topic. So everyone wants to use it, and this kind of paves the way for AI as a service. Sorry. So actually, not only for AI as a service, but like everything as a service. It all started with infrastructure as a service. So cloud hosters provided like servers and other infrastructure to users. Then in the next step, we have platform as a service and software as a service. It helps businesses to focus on their core business. It helps them, with the costs, because you pay on demand, or you pay as you use. You reduce your development time and investment risk, and you increase your strategic flexibility. But there are some downsides as well, because you're dependent on a service provider and a working and fast data connection, and the offer is mostly limited to standard solutions, and which hinders innovation to some extent. Reduced security and of your data and your transactions, if you have like important data to protect. Okay, so AI as a service is somehow in the middle between software as a service and platform as a service, because if you have to train your model yourself, it's more like platform as a service, because you have to set up a training pipeline. I'll show you later what this is. And if you have a pre-trained, say, neural network, where you can also rent the infrastructure that it runs on with it, then it's more like software as a service. I think it improves the time to value significantly for businesses that use it in their daily business. You can fastly test new approaches, ideas, and just play around with it. And this all without big investments in hardware or software. But then on the downside, it has some problems that I will speak about, because being aware of the problems helps you prevents you from making bad business decisions eventually. So I think when talking about AI and as well AI as a service, it's good to discern two types of AI, like low level and high level. With low level, I mean more the classic machine learning approaches like classification, regression, and clustering, Bayesian networks, reinforcement learning, representation learning, and genetic algorithms. It's like algorithms that can be used for different problems. But you have to put together a big training pipeline, so to say. You have to clean your data, you have to do feature extraction, you have to do data pre-processing in general to put the features or the data problem in the form that you need to solve the problem. Then you train a model, then you do parameter optimization, and in the end, some testing and validation. So I think you need quite a bit of expert knowledge to do this. But if you can do this, if you have the knowledge and the know-how in your team, it allows you the creation of innovative solutions for unsolved and non-standardized problems. Whereas high-level AI, which it's not only deep learning, but it's mostly on the side of deep learning, with all the fancy new networks you have around, autoencoders, convolutional neural nets, long-term, short-term memory, and so on, and the new in the bunch, the generative adversarial networks. They're mostly, or the solutions you do with them, they're mostly problem-oriented algorithms. So you have one network that does face recognition. You have one network that does text-to-speech. So with the AI as a services that come out of it, you solve a standardized problem. They usually have a simple interface. I will show you later this. And at least in the ready trained form, I think they're quite easy to handle for non-AI experts. Oh, whoops. Oh no, I broke it. Thank you. Okay, so the market overview of AI services. When I looked for a simple picture, I somehow liked this one a lot because it's a hype growth market, as much as the field is very hypey. So the whole AI is a very active research area. So the whole service market is very lively. You have a multitude of like corporations and small startups that provide services. This is only some of them. Like in the article I found, there are like 22 service providers, and it's from April this year, so probably it's already outdated. The overview for the big four providers I put down here for low-level and high-level AI. So you see, it's quite a jungle that the providers offer. So it's already quite daunting and get an overview of this whole market, and not to speak of like finding the fitting one for you. So the stability and availability of the service is as to be expected. We have waves of selection consolidation across the market. We have regularly new and improved services that emerge, and all the ones are updated, including the APIs, and shut down, even within a platform. So I think it's not as easy to choose a provider as with SaaS, where the size of the provider correlates with the stability of the service. And it's obviously a challenge to use in production systems. So some usage examples. Here's the Cloud Vision API from Google. You can simply drop a picture in, And it gives you the labels, the logos, web entities it recognizes. So Grumpy the cat is already second, which is good. Then it also extracts text and gives you the structure of the document. And in the end, for everyone, you also get all this in a JSON file to download. So you can do some real work with this if you're a programmer. But usually, this is just the flashy example for doing it online. Normally, you use it by command line. Okay, and then for testing some low-level AI, I was setting up a rich regression on some bike data I was downloading from UCI. It's some weather, seasonality, and holidays, and weekdays, and time features. I split it in training, testing data, and I used some and decided for some metric, the mean or median absolute metric. It's basically what I want to show you is it's not all the same, because I mean it's just an implementation. It's software in the end, and the service providers, they're not really telling you what is behind it, how they implement it. It's not also that you can choose whatever evaluation metric you want to use. So here I had to go for median or mean absolute error because both were not available in all the systems. The first line you can see I compared it to Python sklearn implementation, which worked best for all of it. Then I went to Amazon, and there it's really the most limited I could find, because they only offered root mean squared error as a metric. That was the only one available anyway. And the only regression model they had available is a rich regression. But then, I don't know, they pulled out some really good results, even though I'm not sure if I would trust these results, because they did some grouping and quantization of the input features that usually lose information. So I'm not sure if I would trust these results. But then what I'm saying here is always test what you want to buy, because it's just software, it might be buggy, and So just the user interfaces, I like the Data AQ one, it's really nice with blocks you can put together. Microsoft Azure is also very nice, pull, drag and drop, where you can put your models together. And then the Amazon one, where you have a bunch of settings that are very minimalistic and, difficult to handle or very limited in what you can do with it anyway. Okay. As mentioned, it's services as black boxes. They're not open source. It's not even clear sometimes what algorithm is implemented, what model parameters are used. It can be buggy, so please test before you buy anything. Even though in this little experiment I did, it was difficult to compare the different service providers, because there is no versioning except for one of the providers. Then the high-level AI, they are specialized tasks that are different, that come with different output formats. So you might not be able to compare it one-to-one. And in low-level AI, it's difficult, if you're not having the same evaluation criteria, you can't really compare it. Then, if you have pre-trained networks like the face recognition, like all the deep learning stuff, high-level AI, it's important what is the model trained with. So, because it's learning by example, it's generalizing over data. So, for example, the face recognition, is it only trained on Caucasian faces? Then you can only recognize Caucasian faces, and so on. Since I don't have time, I'll leave the adversarial attacks. And obviously, there's a black box in the black box. Many algorithms in AI are black box in themselves. There was a talk of a colleague of mine at Predictive Analytics this Tuesday. There might be a video on the web somewhere, maybe. and the General Data Protection Regulation that is coming up next year, as you could see in the panel that was previous to my talk. Okay, wrapping up. AI as a service allows everyone, independent of the knowledge, to utilize artificial intelligence. For developers, you have simple APIs, and for users without coding skills like graphical user interfaces, along with detailed instructions and this convenience, as well as the self-marketing of the service providers, suggests that everyone can easily apply AI algorithms. I think this is okay for high-level AI that are applied to standardized problems. But if it comes to innovative solutions where you want to do a fraud detection on some data on your company, it's mostly much more complicated than it is in a Coursera course or in a textbook. And then you need actually some AI know-how and knowledge in your team to do it right. So yeah, I think that's about it. Thanks for your attention.